Okay, let's start. So welcome everyone to the public demo, which we're having as a release demo for 2.0 of ThinEdge. So we released it 5 days ago, or roughly about 5 days ago. So some of you may have already seen it. So today we want to go through all of the new features that have been included. We've, over time, tried to show a lot of these kind of upcoming features, especially regarding like the Tedge Flows, the JavaScript kind of logic you can now slot into your ThinEdge environment, like over the last few public demos. So there might not be a few, like that might be kind of old information, but I think it's a great achievement that we've reached the 2.0. So I'll be presenting everything, but obviously we have a whole team behind us. So a big shout out to the whole development team for making this even possible. So we've done a lot of the work, even the flow stuff. We started work on that like conceptually, I think back in June or July last year. So it's taken really like a long time to refine that idea and then finally have it in a production ready version of ThinEdge. That is a interface that we commit to. So now you might be wondering why the version bump of 2.0. So why didn't we do 1.8? So the reason was that we think there's so many great features in this, and they're actually super large features that it warrants the major bump in version. Things should more or less be compatible with, if you're on version 1.x already, then the upgrade path should be quite simple, and you can just install the Debian package. I will highlight a few kind of slight changes there, just so you're aware, and then go through some of the feature highlights. That we believe is such a big change in the way you can then handle mappers, bridges, custom flow logic with JavaScript, that it really is a powerful extension tool now that you can even further customize ThinEdge to meet your IoT requirements. So like all of our releases, I would highly encourage everyone to look at the changelog available from GitHub. We try to put the highlight, hey, what's the showcase features? And then, so going through those, and that's what I'll be demoing today. But I also like to give a bit of a shout out to all of like the smaller features, and you see it's kind of quite large. Even some of the smaller features and bug fixes, there are some real gems in there, like especially if you've already been using ThinEdge. That is some really added value. It might be a small thing, like the option not to automatically generate the Tedge Mosquitto configuration. That's also included. So please have a look, and then you can also refer to the PRs if you want a bit more kind of background information. So some of the major features of this release is, as I said before, like the Tedge Flows stuff. So the Tedge Flows is basically allowing you to create your own either local analytics rules, mapping rules. This is on the main device or child devices using JavaScript. So it's a portable JavaScript thing. We have an embedded JavaScript engine based on QuickJS. So it's about 1 meg in size, so really small. And that enables us to then basically, you can deploy your own logic. It's CPU agnostic. And it's lightweight. You don't need to create the services. We have configurable bridges now, which is actually a huge leap forward. So previously, all of our cloud mappers were basically like pre-baked cloud mappers. So connecting to Velocity, AWS, Azure, it was like, hey, you have to do it. You have to be happy with our rules, and that's it. Now, and you can only connect to those clouds. Now we've opened that up completely. So you can now connect to any MQTT broker. You can define your own rules. You can modify existing rules. So you can actually, and we've changed the packaging aspect, so you can actually create a Linux package with all of this functionality and then deploy it very easily and update it very easily. With that, we have some like rejigging of some configuration. I'll go a bit, that might be a little bit more technical, but I think it's still worthwhile to mention. because in case if you were looking at the Tedge toggle before, we've just shifted around some of the mapping information and moved it out of there. Same with the built-in bridge, that is now our default. So this means it's a Rust component, which is then connecting to the cloud. So this was already required if you were using, hardware security modules and using a local HTTP proxy, and you need to connect through that before you can get to the internet. So we've basically road tested this for over a year, ironed out all the bugs, and we believe it's ready for prime time to then base on the connection to the cloud. And using that enables all of these wonderful features like configurable mappers and all of those components, because it gives us more freedom over the connection of the cloud and more control, which we didn't have in Mosquitto. And lastly, the last kind of extension of plugins in ThinEdge, that the configuration plugin management system, you can now write your own plugins to do the handling of getting configuration and setting configuration. So you can implement your own rollbacks, validation logic, whatever you want, and also have a dynamic discovery of also configuration. Okay, so that's a lot of talking. Let's go into the actual things. So everything I'll do here will be live, no faking, just to show, hey, this is how things will be used in real life. So to start off with this, the best way to, if you're kind of getting, hey, what is version 2 about? I want to try some of those features. Maybe I don't want to install it on my device. Like always, we have a Tedge demo container for this, which is representing a real device with systemd and everything in it. So for convenience, we have a nice Go CLI extension. Now I'm just going to spin up a instance. That will, in the background, on my machine, on my dev machine, start up a container which has like a full installation of ThinEdge, all of the bells and whistles. So it's really good for doing live demos for people. And it has all of the real components that you would have in any kind of production installation. And it's already configured. So here we can see that if I just search for Tedge, we're all in version 2. Cool. We might also notice, for the curious people, there's a few extra packages. So we now have a flow software type, which is everything. So a Tedge flow, which in the Velocity world, that could be akin to a smart function. So a flows is basically the engine that executes smart functions on the edge. So these are packages that you can then freely deploy to the device. So with that, we also include pre-built flows, because we also use our own kind of technology for our own functionality. So this means for the Velocity mapper, all of these flows are included by default. Because we're using that, that means you can also customize that. If you want to kind of splice in your additional logic, you can also extend the logic, write your own flows, deploy to the mapper. Another difference, so since we're using the built-in bridge, so no longer is Mosquitto using responsible for the connection to the cloud. This is now the responsibility of the associated mapper. So logically, it makes a lot more sense. So we can see that we now have a new representation of that service, because you can imagine if the Tedge mapper C8Y service, what we see here, that's responsible for the local mapping. But we also need to represent, is the connection up or down? And that would be then represented by this service. So previously, the service would have been called, I know, Tedge Mosquitto something, C8Y. So there is a name change there to be aware of. But for like most users, the difference will be inconsequential. It's just a visual difference. There's a different name than listed in the UI. So now let's go and install some stuff, because I'll use that as a bit of like what does the data model on the device actually look like now, the file and folder structure. So let's install a few things. So I'm going to install tree first, because that will give me a nice kind of representation of the folder structure. And let's install some flows. Let's do uptime, Tedge compatibility layer, and also a local certificate alert which is maybe something I want to do like a local analytics kind of style of, hey, when is the certificate expiring? I need to be warned, I know, 60 days in advance so I can then react to it. Okay, so that's now installed. So if I see here, yes, and then the flows. The important thing to notice about the flows, so you can imagine the flows, you can basically install it anywhere on any mapper on the device. So it's free for you to kind of decide where you slot that in, whether you want to associate it with the mapper that it's kind of doing the mapping logic for, or maybe in the generic local, which is a new kind of local service, which basically just does like, you can use it for local analytics, but that's totally up to you. The functionality is exactly the same. You're just basically tying the flow to the life cycle of that service. So that has some nice properties. If I'm not using Velocity, well, maybe I don't want those flows running related to Velocity. Just stop the service, and that's it. So how does that look like on the device? So let's connect here. So again, all platform features, no local connections. So using the remote access functionality here, and let's go to root. So I saved me a few commands. So I'm now on the device. I've connected via the remote access service from my device through the from my dev machine to the cloud, down to the device, and I now have a secure connection with SSH. So let's have a look at the folder structure. And this is techie, but worthwhile for people actually using ThinEdge. So the very first thing that you might want to be aware of, the Tedge toml, if you look at this configuration, nowhere does it say I'm connected to Velocity. This is because we've moved all of the mapper-specific logic out of the Tedge toml. This has a very nice kind of downstream effects that you can basically package mappers now as a Linux package. You can deploy them very easily. They're independent. You don't need to splice it into the Tedge toml. You can easily add and remove things. So if we have a look, where have they moved to? We now have a mappers folder where that is just a list of subfolders, which includes the one folder per mapper. So for Velocity, we have a Velocity folder. For the local, like analytics kind of mapper, it's called local. Those names are freely configurable to you. You can kind of, so like anything, we kind of encourage people to stick with the name, like for the Velocity, don't go messing around with that. There's no need. But if you wanted to create a second Velocity, a third one, an MQTT service, you can freely define them what they are. We don't really care. You just need to tell the mapper where to get the info from. So in a mapper, we can see that for the Velocity, because that's quite an advanced mapper, because that's doing all of the device management mapping and all of the telemetry data. We have a bridge definition, because this mapper does have an associated bridge connection, because it needs to connect to Velocity via MQTT. So all of the details there on how to do that. A list of the flows. So this is a mix from, these are like built-in flows that come packaged part of ThinEdge, but also those flows that I just installed before. I installed an uptime and a Tedge compat flow. They're also in there. And again, with the cert alert, that's under the local. So the name kind of then allocates where those flows are then installed. So that's the existing flows. Well, how does this actually work? So if I'm creating, let's say if you're wanting to use the MQTT service from Velocity. So it went GA, I believe, on Tuesday last week. So how does that look? So there's a few different options available. So the long-term kind of option, which will be once there's an additional feature goes into GA, you'll be able to have one single MQTT connection to do everything from device management to publishing to custom topics. But until that feature, so it's the Smart REST bridge feature, goes into GA, you'll have to have a second connection. But how does that look like? So we've created a community package. You could also just do this with files that installs a new mapper via device management. That's it. So it's installed. If I look at my services, I have my service, which is actually doing like the mapping of different messages on the local MQTT bus, but also doing the kind of like cloud connection. But we also have the status of the cloud connection. So here I can say my MQTT service connection is up, so it's actually online. So what does that look like then on the device to kind of cement home? If we look at so let's go to the mappers folder. We can see here we have a new folder. What's in that folder? Two simple things. The mapper toml is basically like the entry point. So, oops, COI MQT. All that has in it is a URL. So this URL is then the new MQTT service endpoint from Cumulosity. So it's the new MQTT broker that you can basically publish any topics you want, rather than like the predefined topics like Smart REST topics. You can now publish any topics, which is great for development or like for devices, because you're no longer restricted to how you communicate the information to the cloud or get the information from the cloud. So with this, because I already have a Cumulosity connection, there's no need for me to create additional certificates, because I can just reuse the existing certificates. That's fine. So in the installation of the package, it just has logic saying, hey, are you already configured to Cumulosity? If so, I can easily derive what the port number is. So it just basically swaps the 8883 to 9883, so the MQTT service endpoint, and that's it. It will now then map messages to the cloud. So just to kind of prove this point, just to make sure, I'm not faking anything. So I've defined, so this endpoint is basically defining that anything sent to this will then go to the MQTT service. So here, this could be arbitrary stuff, like an arbitrary topic. This is just something that I kind of made up. And because I have something sitting on the server side, for Cumulosity people in private preview, the inbound data preparation, so I have a rule which is listening to this topic on the cloud and then converting that to an event. If I just send this, because this isn't publishing to the standard Cumulosity event endpoint, and if everything works, that is created via the MQTT service, via a custom handler, which is then translating this and even adding like enrichment information to it, all automatically using purely MQTT service. So that opens up a whole host of like use cases. You can do fancy things like protobuf encoding to minimize the payload bandwidth, or like the payload size to decrease the bandwidth usage, especially for mobile devices, to just normalizing like data. That's all then possible. And ThinEdge enables you to kind of then make use of the MQTT service very, very easily. But you might be thinking, yeah, like when I've installed that, like what does the bridge do? Because when you install things, you're going, well, I want to understand it. How do I use it? So James put in some very nice work that, we have a command for this. So if you've installed a bridge, we now have an inspect command. And I can see here that I now have so this is the custom mapper for the MQTT service. So it's really just a dumb mapper. It's not doing too much. It's just mapping like a local topic to a remote topic. What topics are these? It's easy to see from the bridge inspect. And this shows me everything what the mapper is doing. So this specific mapper. So everything that I publish on this topic will change. Well, like everything after that / will then be transferred to the actual topic on the remote. That may be still abstract. But having insight into that is very, very useful in a human consumable format or AI consumable format, because this is very easy to reason with. Anyone who's ever looked at the Mosquitto bridge rules knows that this isn't always the case. That is incredibly difficult to wrap your mind out because it's a weird layout. This is a clear concise, where's my data mapped to on the topic layer. So for instance, so this is from the com velocity. So all the mappers will have this, that we can see that, yeah, for the UAT topic, that we just basically get rid of the C8Y prefix. You can see what mapping rules are there. So if you add your own, those custom rules will also show up there. So it's very transparent. But the next thing is, so if we look at this again, you might go, well, actually, I'm not that familiar with MQTT. What does hash mean? So maybe you want a bit more in your context, because maybe you're talking to your users, hey, publish here, this will get published there, especially if you're writing the MQTT service like a component on the cloud side. How do I kind of manage that? So we have a similar command where you can test things. So if I just give it a C8Y MQTT at foo bar, it tells me where that will be routed to. So this is my thing that I'm publishing to. And then the mapper will go, okay, yep, this will get routed to just foo bar on the outbound. So if you're then in com velocity and using the inbound data preparation, you'll just be basically then defining this is the topic you're listening to. So it's very easy to kind of then discover new things and then to debug things as you go. So I think that's quite important for new features, that being able to basically self-document things a very, very kind of awesome, rich feature. Yes, you can chain flows. So I would kind of, I'll look at some additional, I'll point to some additional documentation to go. So we've done a lot of demos in the past which go into the more nitty-gritty details about also flows and how they interact with bridges and stuff like that. So we can go through that or refer to the videos and documentation. So the MQTT service, I would say that's kind of like the easy, because it's really just, hey, here's the endpoint, that. But what happens now if I wanted to create a new mapper to a new cloud, which is totally fundamentally different to anything that we currently have? So that is now possible using the same kind of techniques. So what we can now show is, so there's a things board community package. This is very opinionated in terms of like the package, because we've had to map a lot of things because we didn't know where to map them to. So it's not meant to be a, hey, this works for you, but the principles are exactly the same. So here I'm going to install the things board mapper, which is purely just doing the connection to the cloud. Now this won't be auto-configured. So I'll need to kind of configure this myself because it needs credentials to then connect to the cloud. So to show this, I'm just going to, let's say, add a new device. I'm just using the same device ID that I had before. Let's go to credentials, copy that, add. Now I'll need to go down to the device. I could do this from configuration management as well. That would also work. But just to kind of save time and editing stuff. So we can see we have a things board folder. Going to add the token, and this will be not valid in a few minutes. Then I just need to start it. Edge mapper, oops. Things board. Okay, so we should see a few things here if I go to the right tab. Services. So again, as before, we have full transparency over what is running on my device. What cloud connections is it actually doing? Because maybe you want to restrict it and go, hey, you should be connected to things board, or vice versa. So this is connecting. We can see it in things board. So I go refresh. Cool, it's now active. But I mean, what is a mapper? Like a mapper is more than just the connection to the cloud, right? So that is just a bridge, which is kind of a dumb mapping between topic 1 to topic 2, or a local and remote kind of namespace. We actually want to do something with this. So this is where flows come in, because each each mapper has the ability to also run flows. So we also have some flows for things board. I can just do here, things board. So we have 3 because they're doing kind of different functions. So you can kind of opt in or out of whatever functions. We have a generic registration, which is converting registration messages to things board entities. You can do your own RPC handling and telemetry. So if I just install those, I don't need to restart any services. That just happens kind of magically due to the hot reload nature of the mappers and flows. So we look here, it's done. And if we go here, refresh, voila. So everything, so this is where, my comment on we're very opinionated how we do this. So we're also giving transparency about how to show data from services, child devices, and all this stuff. This is a very, we just wanted to show, hey, everything's possible, but in reality, you might not want it. It's very easy to change these flows and then customize it to your liking, because it's always going to be different kind of, everyone will have different preferences. But the key thing is, so not only did it register entities, so devices, but we can also get telemetry data that is sent automatically. So, and this is also, so this is the data already coming on the generic ThinEdge topics. This is automatically propagated to ThingsBoard. So I haven't needed to do specific ThingsBoard, like, hey, on the device, all of my components of my device have not changed in terms of publishing the telemetry data. It's just the mapping which is doing something new. So we also have attributes here. So these are actually attributes from that other flow, which is also then doing metrics on the uptime. So how connected am I? And dropping, calculating am I, the interruptions, is my connection flickering? Because that might be an indication that my antenna on my device is not properly installed. I need to kind of fix it. So all of that you get kind of for free. And so we believe this combination of flows and custom bridges and custom mappers really is a huge, huge feature which enables people to have their own rich kind of implementation of whatever cloud. So we've had previous customers that want to connect to Google Cloud or Azure Grid, MQTT endpoint. All of that makes this possible. You can package it. It's easy to deploy. It's easy to modify after the fact, because as your requirements change, you might want to do different flows. All of that is now possible without writing a single line of Rust. So it's very easy to kind of, you don't need to get bogged down in the details, writing a service definition, have a process always running. You can make all of our advantages, or take advantage of all of our kind of minimal Rust footprint as easy as possible by just kind of slotting in the JavaScript and then the configuration files. So what else is great at creating all of these configuration files and flows, which is just JavaScript? AI. So half of our flow examples are prompted maybe with a 4-sentence prompt to generate the examples. So one of the examples, or if you're looking for kind of a immersive tutorial on how to write a flow and progressively go from example to example, slowly introducing more topics, that's what this documentation is for. So it would try to introduce all those topics for you, but also at the end, we have, let's say, once you get beyond trivial flows, you generally kind of want a classic kind of development setup. So you maybe want to write stuff in TypeScript. You want to have Jest unit tests. You want to have bundling and all of that automatically because you want to pull in dependencies and all of that stuff. So in our Tedge Flows examples repository, this is where all of those examples are documented. And you can also use this repository as a template. Take our CI rules. We have automatic releasing based on release please and everything. So you can take advantage of this. It's a multi-NPM workspace, but then you can go into the details. So for example, for the Tedge compatibility layer, this was, let's say, 95% produced from AI, referencing to a ThinEdge doc saying, hey, this is our compatibility layer to for these topic translations. For the 0.x releases, we had a change in MQTT schema. Pointed it to that document, say, hey, can you produce a flow? Here's the example flows. That was it. Had to maybe remove one thing, but that's it. So it's really a powerful extension tool because the more that we can kind of take over for like the heavy lifting, the easier it is for AI to then kind of do all the rest and save you working on the harder problems. So that kind of stems on to a little bit of the deprecation kind of notices. So with the deprecation, with the move to 2.0, we finally deprecated the Tedge/topics. So these are really, really old topics. So I think we marked as deprecated back in, I don't want to say end of 2023, maybe 2024, but definitely over a year and a half. So we believe time's now to get rid of it. That meant we could delete 800 lines of code, which weren't really used by that many people. But we understand that if you still have components publishing to it, then install this flow. This will do the mapping, what we previously did in Rust code, this will do it in the flow code. So it's very easy to also then opt out. So you can just delete the flow when you've updated all your components. But there's also an easy compatibility layer with also the additional benefit, showing examples like why the flows concept executing smart functions is such a great idea. Because it's agnostic, you can roll it out easily. It's all hot reloaded. You can remove it when you're not when you're finished with it. So that's very powerful. So if you have a lot of components which are still using the very, very, very old Tedge/topics instead of the TE topics, this is just a compatibility layer that you can easily install. So the last feature, just looking at time, that we kind of wanted to highlight is then the configuration plugins. Where was it? Yeah, configuration plugins. So we have documentation on how to write configuration plugins, which go into all the techie details. So I don't want to focus too much on the technical details here. I want to focus on more like why. And what kind of use cases does this enable? So if we look back at our device, I've now deployed 3 flows on my device. They're running, but each of the flows also have parameters that we wish to configure. So if you looked, I think maybe our last demo, we kind of went a little bit more details on, hey, this is kind of the params.toml. This is how you can kind of like create a user interface for what values are you expecting users to be able to edit to then control the behavior of flows. So you can actually manage all of this via configuration management. But if we have a look a little bit on the file system, just to kind of highlight the problem and the annoyance. So the files that I want to configure, you'll see that there's a lot of params.toml.template around the place. So if a flow says, hey, the users can configure me, this is where it's documented. So this is kind of like the public interface to flows that's saying, hey, what values can I play around with? Of course, you can still play around with the JavaScript code if you really want, or JavaScript code. But the idea is to have like formal places where you want users to kind of fiddle around with. But here you see, like, because flows are kind of like a dynamic thing, I can install them at runtime, remove them later on. If I had to manage all of these things in the Tedge configuration plugin, I would always have to add in an extra entry here. I need to do this. Every time I add in a flow, I need to do this. That's super annoying and doesn't really scale to a kind of modern kind of setup. So I'm going to do a little bit of magic. I'll explain it in a sec. Just takes a bit of time. So I've kind of done a bit of like meta configuration management here. So in the end, the configuration plugin like all of the plugins, so we have like software management plugins, log plugins, and now configuration plugins, they all follow the same style. So it's some kind of executable thing. Could be a POSIX shell script. It could be a binary written in C#. We don't care. But that has a CLI interface, or like a command interface. We'll call that at different points of the lifecycle. Like for getting a configuration will be get config. Setting a configuration, set config, and you pass where to set it from, or like the file to set. So with that interface, we then, the ThinEdge agent will basically go, you've added a plugin here. I'm going to execute you because part of that is list the types associated with your plugin. And you might see now, I have some more types. So these are flow params. So it's kind of like a subtype of configuration types. But we can see here, the Tedge compat, uptime, local set alert. These are actually the configuration files related to each of my flows. I didn't have to manually define anything. So what I did was the magic bit. If we look at the Tedge configuration plugin, configuration. So this is basically used to manage the configuration aspect of ThinEdge to saying, what should I present to the users? Previously, we only had a file capability to go, if you give us the file path, we will then allow you to manage it. But when we start to get a little bit more dynamic things, like going, well, I don't actually know the files ahead of time. I know them at runtime. How do we communicate that? So that's where the role of a configuration plugin comes in, going, I know everything about that. So ThinEdge is able to execute those interfaces from that plugin, and the plugin provides the missing information. So with this, the magic bit that I did was, plugin is actually just a shell script. So typically, I would probably encourage people more to execute it as software or like install it as software, but you don't have to. So here, I actually installed the plugin using configuration management. Needs to be executable. Then I just reloaded the page, and then I deployed a new configuration here, here, where I've just added, because I wanted to kind of manage editing that file, so I've deployed that, and then afterwards, that flows params will execute by the Tedge agent, and then that then presents these options. So what this means is I can now see the configuration aspects of this flow. So now I can change it. So if we have here, so this is for the certificate alert. I want to maybe change a threshold for the certificate alert. So I'm not happy with this alarm threshold, or maybe like either the alarm or warning. I'll have to see what I changed. So just to show no magic, the alarm list is currently empty. So let's go back to the configuration and let's set a new flow. So what did I change? I changed the warning. So it was previously 90 days. I now want a fictitious, like I want a warning 367 days. This is just something so I can trigger the event, sorry, the alarm, but it's on the warning level. I now have a warning. So I've been able to use, so this is kind of like tie-in point that all of the features interacting with each other make for really, really powerful device management functionality. That I've been able to deploy new configuration related to a specific flow. That's been automatically picked up by the mapper. That's then created an alarm as per my logic. And then the user's informed on the UI, oh, I now have, for whatever reason, my certificate hasn't been renewed automatically. I need to then, because maybe my renewal service is broken, I need to act and do something. So all of these features kind of combine together to create a really comprehensive, rich story for device management on any of your devices. And so this could also be run on the main device or child devices. So all of the concepts I've shown here are applicable for both. So for example, if you wanted local analytics on your child device, you can just install the Tedge mapper local on your child device. And that would just be doing local analytics. So you could do, like we have a journal D, so a log kind of analyzer. I'm going, are you receiving too many logs, and then raising alarms for that. You can then deploy that to a child device. So you don't need all the components on that to also then have a rich story, not just for the main device, but also child devices. Yeah, so I would encourage, so I think that was most of the things I wanted to show live. Encourage, again, to go through the release notes, because there's some real gems in there. Have a look at the documentation, which is referenced from there. Experiment in the demo container, because it's, if something breaks there, it doesn't matter. Like, you can just delete it and start again. So you can really like experiment to understand ThinEdge and yeah, play around with new features. We're still in the process of upgrading all of the downstream projects. So for those who are, so this morning we published the Ruggix bakery images, which is, so there's a bit of a lag in between then updating all of them. We're in the process of updating our Yocto layers as well to install the latest version. I think we're still doing the Tedge container bundle, but all of these you expect to have very soon. So please be patient, but more get used to the new features, and we're hoping that all of the users really see the power within them to really making a very, very comprehensive device management story. And also local analytics and all of those kinds of nicer and more advanced features. I haven't been looking at the chat. I saw there was a bit of answers or like questions that have been answered. Are there any additional questions to ask in our open round?
I'm just curious, Ruben, you mentioned in the beginning that I think this QuickJS engine comes with with a footprint of 1 meg. So sort of, by moving this mapping logic into the flows, if I got it correctly, does this mean additional overhead for the devices, in terms of resource usage, or is this negligible? Because
negligible. So I think the biggest kind of resource increase would be the disk space, because it is about, I think, uncompressed 1.2 megs, I think, when we measured it. Considering, I think, all in all of our binaries are maybe, depending on the architecture, around the 17 meg, 18 meg thing. So if you compare it to any other kind of, Go-based thing, that will be much higher. Java-based thing, forget about it. So in terms of memory, it's a very low footprint. You could also just not use flows if you don't need them. So it's an optional component, especially for a lot of, like for the the Velocity mapper, you need the flows. But it's purely optional. You can also control, so that's a good question, list. You can also control some of the runtime metrics if you want to limit maybe the stack size, the overall heap size, which is allocated to the flows. So because everything's running in a very tight sandbox, it's minuscule in terms of the overhead. If you were to run your own process, you're instantly looking at least 5 megs.
Okay, but just that's sort of, it was a lot of information. So, but it means that you said it's optional. So if somebody just wants to use ThinEdge, to talk to Cumulosity, it's not mandatory, right? As of
for
now.
the Cumulosity mapper, yes, it is mandatory because we do our own logic. But if you wanted to do a pure MQTT service, then no, it wouldn't be mandatory.
Okay, all right. And in terms of throughput, it's not an issue. So did you test sort of pumping thousands of data items through this?
No, we didn't explicitly do any kind of performance testing on that bar. Our normal kind of, we have a 2.0 saddle devices, which are running a bit of performance testing. But no, we believe it's negligible.
Okay, cool.
And with the addition that it's CPU agnostic, so the advantages, I think, most of the time, your limitations are going to be disk and the throughput of the devices, especially if you're running like, Raspberry Pi 1s and stuff. It's usually a CPU limitation more than a Rust-based, because it's also C-based, so it is quick. Yeah, maybe one thing that just might be interesting for people who want to imagine what the future looks like in terms of so Tedge demo, MQTT service. If you have enabled the Smart REST bridge already, which is in a public preview. So I think if you have admin access to the tenant, you can enable this yourself. If you want to see what ThinEdge is like connected via the MQTT service and only via the MQTT service, then we actually have an option MQTT service here, which I'll just spawn a new instance. And we do a feature check. Hey, the MQTT service Smart REST feature is enabled. So that's required. I think we might even enable this. I have to double check. But once that's, you'll see here that when we do a connect message, it's only using the new MQTT service endpoint. So this means all of the functionality. So I know we're requesting this. That is going via the MQTT service. So part of the feature on the Velocity side is basically reusing, hey, you want kind of freedom of topics, but we're going to reserve those existing Smart REST topics and then basically forward them to the same underlying infrastructure on the core side. So it's basically like a seamless bridging layer. So you can only have like the overhead of one connection without having to. We don't default into this yet. You could, but given that the proxy is still in a public preview state, we do not recommend using that feature in production because like any per the Velocity feature kind of lifecycle, until it's kind of GA, so generally available, things can change. So, but it's good in the testing, getting familiar with it. There's a few caveats, which I believe are documented on the Velocity MQTT service side. But at least it gives you a chance to kind of play around with it and then play around with the inbound data preparation and things like that, or write your own kind of custom microservices. So that's also very easy to do with a one command, again, just adding an additional kind of argument to starting the demo container. Cool. Don't be worried if you didn't understand all of that. It's a bit of like a mixed audience, and we do a lot of this stuff for our videos as well. But I think just having some broader understanding of the advantages of switching to also the file system-based restructuring that we've done, I think will open up some really, really great possibilities on people writing more extensions, custom mappers, and things like that. And if you're reading our documentation saying, hey, I don't understand that, please create a ticket for us. We're always looking to improve our documentation. So we're happy to kind of have a discussion how we can make that better. Okay, on that note, then thanks for joining the release demo, and we'll see you in the next public demo in, I guess, 3 weeks' time.